Ionic bonding, the transfer of electrons. What is ionic bonding? The atomic theory describes electrons moving about the nucleus of the atom in energy levels. Electrons in the outermost energy level are called valence electrons. These valence electrons of an atom form chemical bonds between atoms. Ionic compounds are formed when one or more valence electrons are transferred from a metal atom to a non-metal atom. The metal atom becomes a positive ion called a cation, and the non-metal atom becomes a negative ion called an anion. The two oppositely charged ions are attracted to each other by a force called an ionic bond. Now, let's focus on ionic bonding. What is ionic bonding? To answer this question, we're going to use an example with sodium, Na, which is in group 1, and chlorine, Cl, which is in group 17. Na being in group 1 is a metal, chlorine being in group 17 is a nonmetal. So let's start by drawing the 3 orbitals for sodium, positioning the electrons. Now it has a full second orbital, but only 1 electron in its 3rd orbital. Now we'll look at chlorine. It has 3 energy levels, 2 electrons in the first orbital, 4, 5, 6, 7, 8 in the second, 1, 2, 3, 4, 5, 6, 7 in the next 3rd orbital. So what will happen is the electron from sodium will move and join with chlorine to produce an outside full orbital for chlorine. So it has given up one of its outside electrons. So what will happen is that sodium now will have its outside orbital of group 2, of shell 2, full. But because it gave up 1 electron, it has 1 more proton, and so it has a plus charge. Where chlorine, on the other hand, has its 3 orbitals, with its 8 in the second, and before, where it had 7, now it has 8, but it has 1 more electron than proton, so it has a negative charge. So a plus and a negative will then allow it to become an ionic compound. So when an electron is transferred from one element to another, such as in sodium chlorine, this is the formation of an ionic bond. Properties of ionic compounds. They're solid at SATP. They have high melting points. They are electrolytes, and they are electrically neutral. The anions and cations in an ionic compound are locked in a regular structure held together by the balance of electrical bonds and repulsion. The most common model of ions shows the spheres arranged in a regular three-dimensional pattern called a crystal lattice, shown here. Elements within a chemical family or a group, the columns, tend to participate in similar chemical reactions, producing ionic compounds with the same general formula. Group 13 to 15, except mercury, will form ionic oxides, which are compounds composed of a metal and oxygen when burned in air. Group 1 and 2 form ionic compounds with oxygen. Group 1 have the general formula M2O. Group 2 has the general formula MO, except of course magnesium oxide, which has a very high melting point and is used to make objects exposed to high temperatures, crucibles, furnace liners, and thermal insulators. Group 1 metals readily reacts with group 17 elements to form ionic compounds with the formula Mx, which is a metal and a halogen, and are called ionic halides, found in underground deposits and used for road salt, table salt, and as a reactant in many industrial processes. So what is a stable octet? A stable octet has a full shell of 8 electrons in the outer energy level of an atom. Noble gases are stable and virtually inert. These are the group 18 elements. Ions with 8 valence electrons appear to have species stability. A group 1 element will lose 1 electron to have a stable octet configuration, and it becomes a charge of a +1. A group 16 element will gain 2 electrons to have a stable octet configuration, giving a charge of -2. Hydrogen is a special case. It can either give up an electron to be an H+, or to gain an electron to be an H-. More on ionic bonding in the next video.